Okay, so one of the things we're starting to look at are inverses. What does it mean to be an inverse? The idea of an inverse is the ability to undo what has been done. What is an inverse function here? An inverse function is a function that kind of undoes a given function. We'll look at this and learn more about what an inverse function is over the course of time. What is the notation for an inverse function? The notation we use for an inverse function will look like f inverse of x. Please do not get that confused with the reciprocal symbol on your calculator. On your calculator, you'll find an x to the -1 button. That is not, repeat, is not the inverse function. It is the reciprocal function, and they are not the same thing. So in answer to, is the inverse the same thing as the reciprocal? No. Do all functions have inverse functions? Let's just say no. They do not have all have inverse functions. We'll figure out how to check on them here in a little bit. Review what it means to be a function. Remember that one of the biggest things we used to tell if something was a function was we looked at the graph, and if you applied the vertical line test, it was a function. When you put the vertical line on any graph, if it hits that graph in only one location, it is a function. Now, what we're going to do here today is apply a horizontal line to our graph and answer that if it hits the graph only once, it's a one-to-one function. So this graph that I've just sketched out here is not a one-to-one function. So when we look at this question, what then is a one-to-one function? A one-to-one function is a function that each x is partnered with only one y, and each y comes from only one x. So when you don't have multiple x's or y's going different places, you're probably looking at a one-to-one function. Let's turn the page and practice a few of these. Okay, so I will be attaching this document to this email as well, so you'll have it if you weren't in class today. But we're going to look at number 1 here, and this is the one out of my book, so the answers are already shown, so we'll just pretend like we don't see that. One of the things you're going to look at is just, I know it says do not use a calculator, but we're going to use a calculator. One of the things you're going to look for is the graph of this function, and we probably recognize the graph of this as being a line. And if you didn't know that, just put that in your calculator and graph it. You get a line, and when you apply a horizontal line to that line, no matter where you put it, it hits the graph in one location. So this is a one-to-one function. So you can proceed in looking at all of these and just graphing them and determining whether the horizontal line hits in more than one place or not. Number 11 through 16 have already been graphed. We don't see the equations that cause them. But applying horizontal lines to those graphs, if they only hit one location, then it's one-to-one. On number 13 here, a horizontal line would hit a horizontal line many locations, and so therefore that is not a one-to-one function. So now we're going to look at how to tell when two functions are inverses of each other, or if they're not, for that fact. Let's come up with one function. Let's call it x minus 6, and let's come up with another function. Let's call it x plus 6, and let's see if these are inverses of each other. In order to tell if they're inverses of each other, we run through the composition of f composed with g of x, and we'll have to do the reverse of that as well, g composed with f of x. A quick review of composition basically says that you take this inner function and put it into the other function, into the outer function. So I'm going to write this g function replacing the x in the f function. So x plus 6, then minus 6. So now my parentheses really aren't doing anything, so I can just say x plus 6 minus 6, and therefore the answer is just x. Let's see what we get when we do g composed with f, which means that the f function is put into the g function, which means that x minus 6 is put into the x position of x plus 6, which would look like this. The parentheses again aren't doing anything, so I would have x minus 6 plus 6. When those cancel out, it's just x. If you get x in both results of f composed with g and g composed with f, they are inverses. So yes, these are inverses of each other. Okay, so let's do that again. Let's pretend like a student says this function 2x plus 4 has been given to them, and they for some reason think that the inverse of 2x plus 4 is 2x minus 4. So we try f composed with g of x, and we take g then and put it into the f function, which would look like this: 2 parentheses 2x minus 4 plus 4. We want to just simplify, simplify, simplify until we're done. So 2 times 2 and 2 times 4 would be 4x minus 8 plus 4. So 4x minus 4. And since that's as far as I can simplify, and that does not equal x, then we realize that these are not inverses of each other. And you don't even need to check the other one, because if the first one does not come out to be x, then you know they're not inverses. So in summary, what types of functions will have an inverse? Only functions that are one-to-one have inverses. What does it mean if a function is one-to-one? It means that one particular x will always be seen with one particular y. Y comes from one particular x. How can you tell if a function is one-to-one? The simplest way to tell if a function is one-to-one is to do the horizontal line test on a graph. How can you tell if two functions are inverses of each other? As I showed you, there was an algebra approach where you do f composed with g of x and g composed with f of x to see if you get x both ways. I am going to show you on one more slide how to tell if two things are inverses of each other via your calculator. So hold on for one more slide.